Welcome back. We're going to write some code now. So let's say you were given this min-term expression here, g, function of a, b, and c, defined by the sum of the min-terms on rows 1, 3, 6, and 7. That basically represents a truth table. So we know we have three input variables, a, b, and c. These are our inputs. And those are going to be all possible values of zeros and ones. And you can build these input tables just by doing this pattern, 0, 1, 0, 1, 0, 1, 0, 1, and then 2 zeros and 2 ones and 2 zeros and 2 ones, and then 4 zeros and 4 ones. So that's the input pattern counting from 0 to 7 in binary. You could put the row number on here just to, in decimal, just to make it a little bit easier to see, to find the rows. So we're given this expression g that's defined by the sum of the min-terms on rows 1, 3, 6, and 7. So row 1, 3, 6, and 7 are ones, and the rest of them are zeros. I'm just going to leave off the rest. So the min-terms are going to be, so what we're trying to do is we're given this definition of a truth table in this notation. And that comes from some problem that somebody's trying to solve. They need a device, they need a circuit that will light up on these particular rows. Okay, you would need to take maybe a digital logic class like Engineering 303 to get a little more detail on that. But anyway, we're basically given a truth table, and we want to find the circuit that'll do it, or we want to find the Boolean algebra expression for that circuit. So we need, the process is we're going to use sum of products, or SOP. So by product we mean and, really, and by sum we mean or. So the min-terms are the sum. So we need a min-term on the rows where the ones are on the rows where the output is 1. So we need one here, 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 and here, and they all look the same. They all are the whatever inputs we have, in this case 3, listed together, and then they differ and they're not. So there's a 0 here and a 0 here, so we'll not the A and we'll not the B. There's a 0 here, so we'll not the A. There's a 0 on this last guy. So basically G is it's the sum of these products. So it's A naught, B naught, C, or A naught, B, C. It's this one or this one, or this one or this one, or A, B, C naught, or A, B, C. So you could build this and out of gates, and it would produce this truth table. And great. We can write a program to do this. A few things. Before we do that, I did come up with a different notation for the files. I wanted it to read these tables, which is basically the column, because the input column is the same for any set of inputs. You're just counting. The only thing you really need to store is the G output. You could store it in this format. I don't know why I didn't do that, but for some reason I came up with another format where I'm just listing ones and zeros, all of them. I guess it was a little, I don't know, it's just what I did. So we need rows 1, 3, 6, and 7. So let's see if I can do this. There's 0, here's row 1, here's row 2, row 3, 4, 5, 6, 7. Did I do that right? We need ones on rows 1, 3, 6, and 7. So 0, 1, 2, 3, 4, 5, 6, 7. Okay. So this is another notation that I used, and I specified text files that basically have this data in them. They basically have this strings of zeros and ones that you can dump into this G column. So if you were going to code this, one way you could do it is make a big old table here, and these are the rows. You could so these are the rows. You could put the columns here, So 0, 1, 2, 3, 4 is your columns. So if you have 3 variables, you're going to have 2 to the 3 columns, or 8 columns. Numbers are going to be from 0 to 7. If you have 3 variables, you're going to have you're going to have 4 columns that are just binary numbers. You're going to have these 3 inputs and then the output column, right? So you need for 3 input variables, you need a matrix. You need this part of it here. So it's going to have from 0 to 2 to the number of inputs power minus 1. So if 3 inputs, it's going to have from 0 to 2 to the 3 minus 1, or 0 to 7 inputs. If this was 4 inputs, we'd have from 0 to 2 to the 4. 2 to the 3 and then do the minus 1, or 2 to the 4 and then do the minus 1. So 7 and then 15, like that. And then it's going to have for 3 input variables, it's going to have 3 columns plus 1 for the output column. And then, so if it was 4, you'd need from 0 to 3 plus 1 more for the output column. Then you need these min terms. You need to store these min terms up. So I used an array of an array of strings. And the algorithm's something like first you figure out how many inputs you've got. And you could do that kind of by looking at the data in the output table and doing the log base 2. So if you had 8 values in the output column, you could take log base 2 and you'd get 3, and then you'd know that you need 3 columns like that. I wanted to run from a file, so I thought it'd be nice to read a file that looks like this. Well, this is the name of the file, but in the file, it's just going to have basically this column of zeros and ones. So you read that file in, you fill in this part of the table, then you need to fill in these min terms. And once you have these min terms, you can just string them together like this by looking if there's a 1 in the G column, then you need that particular min term. It's pretty easy, really. Some of the low-level string processing things might screw you up a little, cause you some grief, but algorithmically it's not too bad. And so what does the algorithm kind of look like? Like for this particular guy right here, which is 7 rows and 3 columns. What are you going to do? You're going to fill in, you're going to fill in this by sort of reverse calculating how many rows and columns you need from the output column, right? So you're going to fill in the input column, which I think I've done for you. Yeah, I've done for you. Then you're going to fill in the output column just from the file. I think I've done all that for you, yeah. So I give you all of this. The only thing I don't give you is the min terms and then this. So all you got to do is generate the min terms. How do you do that? The tricky thing is you need to go back and you need to go through each row, because you need a min term on some rows, right? You need a min term on some rows, the rows where there's ones. But then for each row, you got to go back on the column and look at the zeros to figure out which terms to knot here. So that gets, too iffy. The logic gets a little convoluted. It turns out it's just easier to generate all the min terms. It's a little bit, makes the logic a little bit simpler. So that's what I suggest you do, is generate all the min terms, whether they show up in the final expression or not. Just make them all. So then if you're doing that, then what's going to happen? You're going to go down each row. So you're going to write a for loop that goes through counts down the rows. And you're going to look at each column, and as you walk across here, if it's a 0, you write a naught. And then if it's the next one's a 0, you write a b naught. And if it's the next one, So 0, you write a C naught. And you get to this guy, you're going to write an A naught, B naught, C. And then this one, you would write a naught, B, C naught. And then this one here, you'd write A naught, B, C, like that. So you're writing a nested loop, goes down the rows, then it goes down the columns, right? Checking the values in here and generating the minterms in a table of strings. And once that's all done, then after that nested loop's finished, then go back through this guy and walk through the rows. And if if the G column is a 1, then copy this minterm to your final string. So you see a 1 there, you copy that down, you check the next one, you check the next one, there's a 1, you copy that guy down, like that. It's pretty easy. The only other thing you need to generate, it would be nice if this said G of A, B, C, which I think you guys could figure that out, how to make a string that looks like that just for your output. So that's the basic idea. Let's see what this looks like in code, okay? Okay, so here's the handout from the assignment. So I've got a helper source code that's mostly written. You need to finish one function in that. And what it does right now is it opens a file. So this is the name of the file right here. It's SOP 01010011, which represents the output column, the G column, right? It's these zeros and ones on there on the output side of the column, and the code figures out that that's 24 bytes because each one of these is well, it's a byte plus carriage return line feed. Okay, so if you divide by 3, then you have 8 rows. Then you can take the log base 2 and calculate that you got 3 input variables plus 1 for the output variable. That's 4 columns. So this table here is 4 columns, A, B, C, and G, and then it has 8 rows. So that's all done for you. And then you just need to generate these minterms, which mine does, but of course the version I've given you doesn't do the minterms. So generate all these minterms, and then oh, my highlighter's broken. It's not, oh, it's all broken. But and then once you've got the minterms, then just generate the, pick. So you've got a 1 on there, so you need that minterm. You've got a, I don't know what's wrong with my highlighter. I don't know. I'm not going to fix it. Anyway, let's look in the code what that looks like. I got it in Visual Studio here up and running. So this is the CPP file that I've posted for you that partially produces the output. So if you run it, this is what you get. You get everything except the minterm and the SOP expression. So that's all you need to finish. It's a pretty easy program, I think. Let's see. Let's see, where is this thing? You need, sorry about the delay here, but you need to put these, you need to download all of these text files here and stick it in the folder where you have your CPP. At least that's the default for Visual Studio. And if you look at one of these guys in Notepad, like this one here is the one that we're doing, it looks like that. Okay, it's just zeros and ones in ASCII followed by a carriage return line feed. All right. We could open that up in Notepad just to look at it, just so you know what I'm talking about in more detail. But if I open this guy, I can open it in text format, and that's what it looks like. You can also open that using the binary editor that's built into Visual Studio. Open that same file, but open it with the binary editor, and you see that it's got that's the ASCII code for 0 followed by carriage return line feed, right? That's so a new line then another 0 followed by carriage return line bead, another 0 followed by carriage return line bead, and finally, where is it? Finally, a 1, the ASCII character for 1 in hex. It's 31 hex followed by carriage return line feed in hex. So that's what you're getting at. That's where the 24 bytes comes from. So there's, where is it? It's more than, well, it's 24 times 3 because of the carriage return and line feed. Okay. So the source that I've given you in main, it opens up that file here, right? And let's look at that here. Fill table. It's opens the file, winds to the end to get the size, gets file size, and then rewinds back to the beginning. Okay, then because there's carriage return line feed at the end of every line, then you got to divide by 3. Okay, then since that's the output column, then you need to do log base 2 to figure out how many input variables there are. So there's going to be 3 input variables, A, B, and C. So it prints all that junk out. Then I'm filling up the table by reading in the lines and sizing the table. I'm sizing the rows and columns. I guess that happens up here. I'm sizing the rows and columns. Then I'm reading in the G column here. Then I'm filling in the input side by basically counting to 7 and then using a bit masking technique to peel off the bits of those binary numbers, right? Because we're counting, on 3 variables, we're counting from 0, 0, 0 to 1, 1, 1, or binary 0 to binary 7. So I just basically count through rows and columns, and then, take it apart binary wise. You can figure that out if you really want to. You don't have to play with that. I've given you a function that prints the table. Okay, there's some good code in there you might want to look at. What you have to write is this. Okay, so this is the one function that you have to write for this assignment. So you just need to fill up the min-terms. So I made an array called min-terms. That's just the ABC, 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 with all the knots on there. You need that, and then the final SOP expression. So you're going to go through each row. So walk down the rows, and then for each column, you're going to either concatenate a variable or a variable with the not symbol on there, right? So it's either going to be X or X naught, depending on whether the G column is 1 or not. Okay, so some string concatenation in there. And I think where is it down in here? I might have some string concatenation going on. Oh, no, I guess not, but I've given you some hints on these lines of code. You might want to use them to help you with your string concatenation. You can do kind of whatever works for you, but that might help you, right? So go through each row and then look at the values in the ABC columns, and if they're zeros, then you want an X, and if it's 1, you want or rather the other way around. If it's 0, you want an X naught, and if it's 1, you want an X. I mean X, but it'll be ABC as you go down the columns. Okay. Once you fill that up, then you go back and do another row, and you look if G's there, then you need the corresponding, or you need that min term. You need to concatenate that min term onto the final SOP expression. Okay, then you need to build a little thing that says G of A, B, C up to however many variables there are. Yeah, that's it. It's pretty easy. And then run it on this guy, right? But then run it on this guy. I want to see that too. Like, let me open that guy up. Is that him? I think that's him. Or is it the next one? Yeah. That is him. Run it on that. Okay. Gosh, can I do that right now? What happens if I What happens if I do that? Oh, yeah. So it works. So all you got to do is the min term part. Pretty cool, huh? I mean, you need a program to do this. You wouldn't want to do this manually. And there are programs that do this. And then they go further and they simplify this, right? Because this is just an SOP expression, but it's a sum of products expression. It's an answer, but it takes a lot of gates. And we could minimize this with other circuit simplification techniques, but those are too hard to have you guys implement it. All right, so I think you'll have, hopefully you have a little bit of fun with this. It's not super, super hard. All right, thank you. Bye-bye, see you next time.